So in the past, when we've been solving limits, sometimes we fall into the trap of the indeterminate form. For example, sometimes we end up with 0 over 0. And we call that indeterminate form, and we have to find some other way to find the limit. The reason is that there are two forces pulling in different directions. For instance, the 0 on top is pulling downwards because when we approach 0, you're going down. However, when we divide by 0, that's approaching infinity. So we have basically a numerator that wants to go down and a denominator that wants to go up. So that's our problem. If you're still not convinced by my explanation, I have a couple more examples to hopefully convince you. So let's say we have x over x, and we're trying to find the limit as x approaches 0. Well, if we were to simply plug in 0 for x, we'd have 0 over 0, which is our indeterminate form. However, we know that based on the graph and just by basic algebra, the limit as x approaches 0 for x over x is 1. However, let me take you to example 2. The limit as x approaches 0, except our expression now is x squared over x. Same thing, if we were to plug in 0 for x on the numerator and in the denominator, we'll get 0 over 0, our indeterminate form. However, using basic algebra, we know that this actually approaches 0. And I also have a third example just for fun. So we have the limit as x approaches 0, except this time we have x over x squared. Same drill, plug in 0 for numerator and denominator, we get our indeterminate form. However, using basic algebra, we end up with 1 over x, and we know that approaches infinity as x approaches 0. So now you know that when we simply plug in 0 for our expression and we're trying to solve the limit, if we get 0 over 0, it's an indeterminate form, so we actually can't determine just based on 0 over 0 what that limit approaches.